from chapter 4. Questions from homework in chapter 4. And you all like, what the flapjack? I'm glad I got chapter 3 homework looked at. So I didn't say this. If you didn't turn in your chapter 3 homework, you're fine. I didn't officially change the due date. Due date for homework is always the day of the next test. And this wasn't really a test today. But hopefully you were kind to yourself and you did enough homework in chapter 3 to be ready for today. Okay, so we'll see. We will find out. So no questions on 4.1. We did 4.1 and 4.2 because we're crazy. Also, I think on the homework, isn't this the section, if somebody has their homework sheet, isn't this where I added a question for 76 and 77? Just to really make sure you guys see that. Yeah, section 4.2, do you guys see that? Section 4.2, it's asking for more than the book does. If you don't do it, then I'm going to make you do it again. Or, do it for the first time. Section 4.2, it's got a little extra in green. A little extra requirements. All right, so. Let me start off. That last problem, the second to last problem on the quiz. That kind of problem. We've seen that kind of problem a few times. Where I've got, let's say, the one about the salt watermelon and don't salt watermelon, right? So if I say something very specific, like what's the probability, I pick 4 people. What's the probability that the first one salts while the last 3 don't? That's the one we just had up here, right? Right? What the hell's up with that, Jeff? Fran Waller. Isn't that right? So the first one salts, that was just this, times 0.82 3 times. Is everybody cool with that? Yeah. Now, what is the difference between that question and this question? It's kind of obvious there is a difference. What is the difference? Well, one of them exists, Jeff. Well, just give me a second. What's the probability that exactly one of them salts? This is just too funny for me. Salts their watermelon. Is there a difference between those 2 questions? I already told you there is. Can you figure out what the difference is?
Okay. The first one is, I guess it leaves a probability that there could be more than one, whereas this one...
No. This first question is remarkably specific, and the second one isn't as specific. Think about it for a minute. Isn't this one way to do that second thing? How many people in this situation does salt their watermelon? 1. But this isn't every way. So if I have 4 people, right? You 4 right there. Right? Slither in. And, no, it's not that. We got 4 people. And so this would be you salt your watermelon and you guys don't. You guys with me? Is that the only way that exactly one of them can salt the watermelon? No, that's only her so far, right? Yes?
How does that change the probability at all? It's you're still multiplying one person who does and 3 others that don't.
Totally, but you've got 4 ways to do it. So what's the probability? Let's do this. What's the probability to pick any card out of a deck of cards? A king, an 8, it doesn't matter. They're all the same, aren't they? Right?
No.
What's probably get an 8 out of a deck of cards?
4 out of 50.
What's probably get a king?
4 out of 50.
What's probably get an ace? Okay. So they're all the same. Cool? But if I do several cards, of course the probability is going to be different, right? So, now, stay with me. What's one way to do this? The first one does salt, and the last 3 don't. Right? Isn't that what I did here? First one does. B, and the last three don't. Not B. To be. No Shakespeare. Or, and isn't this the first person does and the second person doesn't and that's why it looks like this. What's the operation understood to be? Times, right? Each of the probabilities out and multiply them. Or, what's another way that I could have one person? Not you, but you. So it could be doesn't salt, salt, doesn't salt, doesn't salt. What's another? Now this is really fundamental. This is really, 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 really just basic. I mean, if I got 4 people, how many ways can I have one of them do something? You or 4, right? So if I'm going to make this list, I should have 4 entries. What's another way I could have one person? It could be the first or the second or the third or
Fourth.
the last person. What does or mean? What does or mean in probability? What does or mean? What operation? Addition, right? There's a reason. That's one of the most important things to come out of this section. And means multiply. So in that first problem on the quiz, you better have multiplied 2 things together or else you're wrong. Because it was this and this multiplication. All right, I like it. That's my sign language for multiplication. Multiply.
The thing that I still don't get though is like, say for example, we're not even talking about probability. Like when you multiply, say 6 times 6 times 6 times 5.
No. Okay, here's what you're missing. Your point is each one of these is the same number. But what's the answer to this question is these things added. How do I figure out the probability of something? Don't I have to add up all the things that match what I'm looking for? So if I said I want the probability I get a jack or a 2 or a 7 or a king, now I'm adding more and more stuff because there's multiple ways to match what I'm looking for.
So are you adding all of the
Yes,
answers together?
totally. Because, again, how can I match this? The first person could, or the second person could, or the third, or the fourth. So I'd have to figure out now each of these, what do these look like mathematically? What is B times B bar, B bar, B bar? What's that? B times B bar cubed. Does any of them look different than that? Why does that make so much sense? And you're like, you don't know what words mean, Jeff. So much sense. Because they got 1 salts and 3 don't. Holy shit, that makes so much freaking sense. Please let that make sense. And right now, it doesn't make complete sense. We'll do a few more examples like this, but what number goes in front of this? Because each of these is B, B bar cubed, B, B bar cubed, B, B bar, and how many do I have of them? 4.
How do you do that for like larger sets?
Exactly, we're getting there. Don't worry. I love how you're thinking. Bring it back a sec. We'll get there. So let's do this. Let's make this a little bit easier to look at because the B and the B bar shit is kind of weird. Let's do this. The probability that somebody is left-handed in the United States is roughly 11%. So what's probably somebody is not left-handed?
89.
89%. 11. And I love the people that are like, what if somebody doesn't have any hand? Well, they're here. They're obviously not left-handed. They don't have hands. So together, this covers everybody. Are you with me? And I'm not, because it's happened in the past. Somebody said, well, what if they have no hand? Well, they're there then. Okay. So this covers everybody. I like it. So let's do one little thing for ourselves. If the question would be something like this, pick 5 people. What's the probability that exactly one of them is left-handed? Now we're at the very early stages of this idea, but I want you to realize this is the kind of analysis I can do to help me figure out how many left-handed desks to put into a standard classroom. If I have 50 students and 11% of them are expected to be left-handed, how many left-handed desks should I put in there so that students aren't complaining? You guys with me? Are there any left-handed? I guess I don't even know if. Do we have any left-handed desks in
I
there?
can ride with you.
There's a table, I guess, huh?
I can ride with you.
You can. Oh, well, now you're just showing off. I'd give my left hand to be ambidextrous, but that is supposed to be a joke, but it's just for me. If I pick 5 people, it's a probability that exactly one of them is left-handed. So let me call. So what am I looking for? I'm looking for one to be. All right. So let's call that a success. So a success, it doesn't have to be a nice thing. If I'm out in the battlefield, I'm looking for dead people. That's a success. Not a nice thing, but it's just what I'm looking for. If I'm out in the field, I'm looking for deer. I find a rabbit deer. Success, not a happy success, but it's a success because that's what I'm looking for. You guys with me? Success doesn't have to be happy. It just has to be match what you're looking for. I like it. Okay. So let's give that a symbol. Let's always use the same symbol so we know what the hell we're talking about. The success dude we'll call P. And what do you think we're going to call the other situation? That's probably it's not success, it's a failure. So probability of failure, we'll call that Q. Just cause. Now, can you guys write one situation that matches what I'm looking for? Exactly one left-handed out of 5. So what's one way to match that? No, I want, if I have 5 left-handed, that doesn't match this. You guys see that? I want exactly one left-handed.
P times Q times.
So I can have the first one be left-handed,
Yeah.
and the other ones have to be
Q.
Q's. Let's keep going just to be crazy.
Q.
And then we're eventually going to get to the question over here about what are you doing as a big-ass number. Then, or it could be Q,
Then P.
P. Q. I mean, I want you to realize, fundamentally, all we're doing is, it's got to be one of the 5. So how long is my list going to be?
5.
5. Or it could be Q, P, Q. Or it could be Q, P, Q. Or it could be Q, P. So on one level of this, it's really simple. It's much simpler than it looks, but you got to start connecting the simple idea with the way it looks mathematically. These just represent the first person or the second person or the third or the fourth or the fifth. And each one of these situations is an and, because it would be the first person is, and the next one isn't, and the next one isn't. And that's why these are all multiplications and these are all additions. Mathematically, each one of these looks like what? P times Q times Q times Q times Q. What's a better way to say that?
PQ.
P times Q to the 4th. Why does that make so much freaking sense? Because I have one success. The other ones are failures. There just happens to be how many ways to do it? 5. Somebody really cool with me just putting a 5 there? Because what is PQ to the 4th plus PQ to the 4th plus it's freaking 5 PQ to the 4th, right? So what does this number seem to always represent? How many ways? How big the list would be. And so far we've been able to make the list by hand. But my God. Real quick, we can actually get this number, right? What do I put in place of P? What is P?
0.11.
0.11. What is Q?
0.89.
0.89. And this is where I wowed some people when I can't remember what it came. 0.345. No, maybe. Yes. Is it? No. Maybe not. Is that this one? Maybe it's a different one.
You did 4 people.
4 people. Shit. So this one will be Do it, Jeff. 0.0277? Oh, I don't even know anymore. What? Anybody doing this for me? Anybody help me out? I'll let you borrow my calculators. What is it?
0.345.
Oh, it is 0.345. Yes? Okay. All right, sorry. Woo! So there's about almost a 35% chance that for any group of 5 randomly selected people, one of them will be left-handed. And again, we're at the very basic beginnings of this, but this leads into, for example, how many left-handed chairs to put into a room. It also leads to how many tickets to oversell for a plane. You guys ever been bumped off a plane? You know what that means? That doesn't mean that somebody's mean and just like bumps you off and you fall out right before you go on the plane. Boom, and you're out there helping them put luggage on. So what they do is they calculate. There's a probability that somebody doesn't show up. And what does the airline want to have happen? Any airplane they fly, they want that bad boy to be full. Any empty seats is lost money. So that's why you got stuff like Priceline and bullshit, and you can get a lower price because they want to sell that damn seat for something. Like, please take the seat. But they oversell to make sure that they're full. So sometimes you'll be bumped or you hear, we'll give like $200 to you if you'll wait for the next, and then about 5 minutes later, okay, nobody liked that. We'll give you $300. Have you ever, somebody ever flown a plane? No? You ever heard that kind of announcement?
Yeah.
Some of you guys, sorry. Some of you guys maybe have never been on a plane and you're like, well, that's one more thing I'm not having to deal with. I agree with you. I'm sorry.
Oh, I just had a question about when you would use, like what keywords do you look for in like the questions, to do that instead of like the other way where you said like,
Oh yeah, so the other way I was very prescriptive. This kind of person goes here and this kind of person goes here.
so you'll say the
This doesn't tell me which is what. It just tells me how many.
other. Like the other one will say first.
I'll say the
this.
first one thinks this and the other something don't. Or, the third one thinks this and the other ones don't. And I know exactly what to put where. This one is all the ways. Okay, the real key I want you guys to realize. Well, let me do this. Let me see if you guys can get to a certain point with this. So let's say I had 80 people. Holy shit. You go away. You came back. Oh. Let's say I have, there you go, see? All right. Let's see, I have a marker shape. 80 people, and I want, you can do it, Jeff. And I want, what's probably that I get exactly 11 left-handed. Can you just tell me what this piece right here would look like? P to the what? Q to the what?
ADP.
No.
Or
Don't worry about this number, because what would this number be? That number is always, we said this just a minute ago, how long the list is. Can you begin to appreciate how stupid long the list would be? Because how many ways can you have 11? The first 11 are P's, and the last 69 are Q's. Or the first one is a Q, and the next 11 are P's. Or the first 2 are P's, and then there's a Q, and then there's a P, or fudge. I almost said fudge. Anyway, so do you guys see that would be an insanely long ass list? We as humans don't grasp that too easy, because have you heard the thing about pizza toppings? Some of you guys have, but like how many combinations of toppings are there for a pizza? It's in the millions. It's in the millions. So it's a lot. So it's because once I got a lot of choices and I can do all these different combinations, that number grows fast. This, I think, what it come out to be, I did this with some other people earlier, like, I think it was 1 followed by 13 zeros is how long this list would be. Okay, so The nice thing is, we're not going to do a problem where we make the list because we have to give up on that pretty damn quick, right? What we're going to do instead, what's a way to say this concisely? I've got 80 people. I want to choose 11 of them to do something. Every time I would try to make a list, I'd have to choose 11 to put a P, and the other ones would be Q's, right? So we would say 80, choose 11. There's a function in the calculator I'm going to show you in a minute that you can put in, and it'll tell you how big this number is. So what number always has to go here? How long the list would be. This kind of thing will tell me how long the list is. Yes?
So if we were to get a problem like that, we would have to do
Yes,
this.
good Lord. You could list them out. But again, what is 1 followed by 13 zeros? Do you even know what the word is for that number? It's not a million. A million's only 6 zeros. Do you understand what I'm saying? This one has 13 zeros. That is how long the list would be of the ways to order 11 P's with the rest Q's. Do you guys follow what I'm saying? Do you guys really follow what I'm saying?
Yeah.
It's like, you say stuff, but yeah.
So you know how for that one you said pick 5 people? For this one, are you asking?
Yeah. You have a random selection of 80 people. You randomly select 80 people. What's the probability that 11 of them?
So why, you know how like you put 5 in front of that one because there's 5 people to pick? How come we don't just put 80?
Again, I'm glad you said that. I picked this situation because it was really easy to see how long the list was. We could write it down. Now watch. All right, let's do this. Here's one we can handle by hand that's still kind of long. Real quick, before I get too far away, what would the power be on the P here? No. How many successes do I want? 11. How many failures? Because what is these always have to add up to be the total. Okay, yes.
So would you put 80 in front?
Yeah, so no. Okay. I would put this. Because this is going to be a long ass list. Now watch. Just to show, if I have 80 choose 1, that would be 80. 80 choose 1. How many ways is there to choose one person if you have 80 people in a room? 80 ways. Do you guys understand that?
Yes.
If I had 80 people, I could choose you, or you, or you. I'm not going to do that 80 times. I was thinking about it, but to see what you guys are doing. Slap him. I think he's broke. Do you understand? So 80 choose 2 is going to be way bigger. Because now it could be the first 2, or the first one, or the third one, or the first one, or the fourth one, or the fourth one, and the fifth one, or the second one and the third one, or the second and the fourth, or the second and the fifth. Holy flippin' shit! I'm only at the beginning. That would be huge. So 80 choose 11 is like huge to the huge power. I mean, that's all right. But just to get a handle on this, what was the example I did before? Shit. Oh, that's right. What if I had 4 people and I want to choose 2 of them? So I want exactly 2. So for example, it could be P, P, Q, Q. You guys cool with that? 4 people, 2 successes. What's another way to write this? Just to do it systematically.
PQ.
PQ, PQ. So I'm going to let that P kind of flow. That sounded horrible, but oh well. Let that P flow. So P, Q, Q, P. Jeff, you're so professional. Q, Q, screw you. All right. Or I could do Q, right? And then it would be P, P, Q. So I can do it with a P first. And then, or it could be Q, P, Q, P. Is that cool? Or Q, Q, P, P. So if I have 4 people and I want to choose 2 of them, it actually comes out to be 6 ways to do that, not just 4 ways to do it. So 80 people choose 11. It's going to be crazy, crazy, crazy big. A number we are so not in touch with that is so big. And it might be smaller than a deficit, but still, it's really huge.
So like, because you know how before we only chose one person, is that why it was?
That's why it was just that number, because anything choose one is that. If I had 8 trillion people, what's one? How could I choose? How many ways can I pick one? 8 trillion ways. How many ways can I choose 2? Holy shit. An insane number. All right, so let me show you how to do the choose part in your calculator. Oh, there it is. Turn on. You turn on. There it is. So if you have your calculator, if you have this calculator and you're in a math class, in stats class, obviously the stat button is really big. The statistics is also a math class, so what other button seems like it would be interesting? The button that just says frickin' math. Right? No?
Yeah.
It's like, what the shit is that button gonna be all about? Alright, let's see if I can make this something you can see. Did we see that alright? I think it's alright, okay. So let's hit that math button. Alright. Did I show you that first thing? Real quick, since that first thing, look at what that first thing, what do you think that first thing would do? So if I put in there, go away. If I put in there, what are you gonna put in there, Jeff? I don't know, 77 over 497. One thing you can do, watch, is it'll reduce a fraction for you. If you put 0.258, yeah, change it to a fraction, it gives it to you in reduced. Why didn't they tell us about this in Math 88? Because that's when you're supposed to be able to do this shit yourself, that's why. But now that I'm assuming you can, there you go. Anyway, so there's other shit under here that looks very curious and interesting, right? Some of it maybe you don't know, that's related to calculus. But let's go over to, where's something that would be interesting for our class? Yeah, dude. Probably. All right. Which one do you think relates to what we're doing? Yeah, I like it. Real quick, this one is not National Public Radio, but it's like if I said I want 3 people to come with me, I would count you, and you once, right? And then there's like, I can take all the other 3 people. You with me? This one would be even bigger because I would count you, and you, different from you, and you, different from you, and you. Yeah. All the different ways. This is called permutation. We're not going to use that one. We're going to go straight to choose. This is actually officially called combination because it's the number of combinations that I can make out of so many things. So for example, let's check the one we just did. Get out of here. Get out of there. Hit the quit button. So if I put, everybody with me? 4, math, probability, choose. 4, choose 2. 6. So again, what is that function's, I love it, function. What does that function do? What does that choose thing do? Tells you how long the list would be. So let's try 80, choose 11. 80, choose 11. That E means times 10 to that. That's 1 times 10 to the 13th, roughly. It's even got more shit in there.
To what decimal point would we put it in our equation?
No. So hold on. I'll show you how to work this out. When we do a problem, we're not even going to worry about that number, to be honest. Here's how, is everybody, so that's all the pieces now. We've got what this is all about, and we got what this is all about. And together they make the whole thing. Yes?
So I just want to make sure that I don't get 2 numbers like switched
the total.
Okay, and then the second number is like.
Is how much you're choosing from there. So 80 things, choose 11. If you told the calculator 11 choose 80, it's going to give me an error. Poor little dude. Oh, just give me 0. That kind of makes sense, right? If I had 11 people, how many ways can I choose 80 of them? And the calculator's like, that's the easy problem. You can't do that, buddy. I'm like, oh, yeah, okay. You guys kind of with me? That's kind of nice. I didn't even know what it would do, but that makes sense. It's 0. There's no way to do it. All right. So, watch this. Let's do a fresh problem. This is all stinky smells. Yeah. So let's say the probability that somebody plays tennis. Sure, because that's just what came into my brain. Is 39%. All right, so I went and talked to nobody when it came to these numbers. Just so let's use. So of course I'm gonna. So if I want to know, if I pick 48 people at random, what's the probability that exactly? What you got, Jeff? 21 of them play tennis. You get a feel for this. So let me give this a little bit of structure. These problems are called binomial probabilities. What does the prefix bi mean? Two. Bicycle, 2 wheels, right? Bifocal, 2 distances, you can see. Nomial is kind of like terms, like polynomial. So in this case, it's 2 things that could happen. You could either play tennis or not, right? Believe it or not. So probably they don't play tennis is what?
6-1.
6-1, I like it. I'm going to call this what? What symbol?
6.
No, what symbol?
P.
P, because it's what I'm looking for, right? Play tennis. So that's P, and this one's going to be?
Q.
Q. Craziness. So look at what you can see. I see a probability of one thing, which means there's a probability of not that thing. I see a total number. And then I see a question about a number of successes. So tell me this, what's N for this problem? That's one letter that never changes its meaning.
48.
48. Total number I'm looking at. P we know. Q we know. This one, why is it 21? Because I just picked it to be 21. What could it have been? What could I have put here? Anything from what to what?
1 to 47.
1 to 48.
0 to 48. Could have been none of them play tennis, or all of them play tennis, or anything in between. So obviously that is going to be what I call X, because that's the thing that can vary. We call X in general the number of successes I want, because that's what can vary. And in this case, X is 21. So how do I set up this formula? This formula is almost